Welcome to a concrete stair problem. So this is a pretty long worksheet, so I will try to keep it moving along fairly quickly so that it doesn't turn out to be too long. Let's have a quick look here. We've got a concrete set of stairs. We have a bit of a wall in behind. We have our structure, soffit, and joists that build the supports for our concrete. And we have some measurements here. We have a 30 mil nosing. The effective depth right here is 110. See that our joists are 140 mils, so 2 by 6. Between the concrete and the joists, we have 19 mil plywood. And we have the same up here. We see that our slab itself is 100 mils thick. Our landing length is 1800, so that includes that first tread, the nosing, and the wall in the back here. And the landing width is 900. So the landing width always means that the stair width is the same. We have a desired rise of 180. We'll use the total rise, the 1665, to figure that out. We're using the proportional rule of 630, and we'll get there in just a moment. And then we have a bunch of things to find. Let's get started. Any stair problem, concrete stairs or regular stairs, we always want to find the number of risers first. So we take our total rise divided by our desired rise. So those are just numbers that we can take from our piece of paper. Total rise right here is 1665 divided by our desired rise. That's given to us as well as the 180. And we pop that into the calculator. 1665 divided by 180, 9.25. Can't have 0.25 of a riser, so we'll round down to 9. And we can pop that in here as well. So we're going to have 9 risers. What I like to do immediately is at the number of treads, just pop an arrow pointing downward, because there's always one less tread than risers. So that's just one of the reminders that I like to do for myself. Cool. Well, that's number 1 already. Next, the true rise. And these terms are interchangeable, true rise or unit rise. Same thing. So the amount that each time you step up, you move up in space. So we take the total rise and we divide it by the number of risers that we have. So total rise is the same, 1665 divided by number of risers, just figured that out, 9, 1665 divided by 9, 185. So that is our unit rise. And the desired rise just means roughly in that ballpark. 185. Now, the true run or unit run, again, interchangeable terms, there are several guidelines. This worksheet gives us the guideline of 630. And all that means for any of these guidelines, they are not set in stone. It just means if you make your stair with this guideline, it makes a comfortable stair to walk up. The most comfortable is 32.5 degrees. And that is all that it is. Any of the various guidelines, whether it's 711, 7 unit rise of 7, unit run of 11, makes a comfortable stair, or in metric 450 or 455 equals a unit rise plus a unit run. And this particular one is 630. And to achieve 630, we take the unit rise plus the unit rise, so twice, plus the unit run. And we should come out with 630 or thereabouts, and that is considered a comfortable stair. That is all the guideline is, or a proportion rule, and a worksheet will always give you that. If they want you to use one, they will give you that. So the unit run, right? We have 630 equals unit rise plus unit run. So if we want to find the unit run, we just flip-flop these around. Turns into 630 minus unit rise. So let's pop that in here. And unit rises are 185. minus 185. There you go. 260. That is our unit run or true run that we will use for this worksheet. 260. Perfect. Excellent. Unit of bridge. So the unit of bridge is Pythagorean theorem. So in our triangle of and however you want to draw this, it doesn't really matter. But if we have our unit run, our unit rise, we have our unit of bridge here. Right? So a squared plus b squared equals c squared. Unit rise plus units run squared. Take the square root will get us the unit bridge. And the unit bridge is part of the nosing line. Right here, I'll draw it in right here. That right here. It's just a portion of the nosing line that goes all the way down, touching all the nosings. And that is the unit of bridge from a unit rise and unit run triangle. That is the hypotenuse. So let's pop in those numbers. Unit rise, we know that. 185 squared plus unit run. We know that as well. Lucky us. Perfect. So punching that into the calculator, look, the 260 is still in here, so we can leave that squared plus 185 squared equal button. Second function, and that same square button gets us the square root. Gets a 319.1. And that is our unit of bridge. These three numbers, we will use them over and over and over in this worksheet. 319.1. Perfect. Next, number of treads, always one less than risers. So number of risers minus 1. So we had 9 minus 1 gives us 8. 8 treads. Perfect. Number 6, total run of the stairs, meaning the total run, if we were to look at it just on a horizontal basis, is the number of treads, right? 1, 2, 3, 4, 5, 6, 7, 8, times the unit run. So 8 times 260 gives us 2080. Cool. Easy peasy. You will do all of these for any stairs that you ever do, whether they're concrete stairs or regular stairs. So it's a good idea to just get really comfortable with it and understand where everything is coming from. Wonderful. I will pop this sheet up here a little bit out of sight, but accessible should we need it again. Next, let's find out what we have to find next. X, the hypotenuse of the effective depth. Okay, what the heck does that mean, hey? So 110, that's our effective depth, meaning we need a slab of concrete below our triangles, right? If we made the set of stairs in a way that we only end up with triangles, there's nothing to hold the whole thing together. So that's the effective depth. Per building code these days, it's 90 mils minimum. So this one exceeds that a little bit, which is great. I'm going to draw this in and hopefully you can see it. And I'm going to draw it in up here. So this is our effective depth. And imagine this is our hypotenuse. So we're making ourselves a little triangle up here. And that right there on the top is our X. And we'll need this later for the calculations of the slab. So that's why we do this. So the up and down or the rise of this triangle is the 110. And then the hypotenuse is the X that we're trying to figure out. So for this question and many more, we will be drawing triangles. So good time to get used to it, get practice drawing triangles. and we will be comparing triangles. So let's see. What do we have? 185 is our unit rise. 260 is our unit run. And 319.1 is our unit of bridge. We will be using this to compare everything else too. The rise is comparable to the effective depth, right? They're on the same side of the triangle, and we want to find out the hypotenuse. So which numbers could we compare to each other? I would compare the rise and then to the hypotenuse. And I always like to keep them the same. So 110 over x, because this is x, right? So 110, which is our rise over our hypotenuse. And we have to do that on both sides. On the other side, we have 185, our unit rise, over 319.1, which is the hypotenuse of that other triangle. And then we cross multiply and divide. So 319.1 times 110 divided by 185 should get us 189.74 or 735. 189.735. That's it. Swoop. Pop that in here, 189.735. And really, we could also call that 190. Okay. Why? The run of the true rise minus the landing slab. So the most difficult part of this question is to understand what the heck it is even asking. So for this, we get to draw another triangle. Yeah, I'll show you this, and then I'll show you where that pops up here. So again, we have the same triangle as before. We have our unit rise, we have our unit run, and we have our unit of bridge. We're trying to find a unit run, which we call y. And what we're trying to find it of, I'll draw it in red up here, is if you imagine from here to the top of the slab, that is our entire unit rise. What we're trying to find is the unit rise of this little bugger right here, and then to find the unit run of it. So basically the unit rise of this little triangle and unit run of this little triangle that is left over when we subtract the slab from our total unit rise. So let's look at that. Our unit rise is 185. Our slab thickness is 100. So that leaves us with 85. So this little rise right here is going to be 85. So for that little rise, that is what we're trying to find the run for. And again, we'll need this later when we're calculating slab or landing slab things. That's why we need it. So which means for here, that's our 85, right? And that's where we get that from. We want the run of the true rise minus the landing slab. So basically the leftover rise once we've taken away that slab thickness. Okay, so again, we cross multiply and divide. What can we compare? Well, we have unit rise, and then we want to compare it to the hypotenuse. So 185 over 319.1, right? Rise over hypotenuse equals to, what can we compare here? Well, we have the 85 over y. And that's not true. I'm sorry. We didn't want to do any of that. My apologies. Let me redo that. Droop, droop, droop. And as always, I leave this as part of it because this is part of learning, part of doing things, part of doing math, part of double checking yourself. We don't want to find the hypotenuse. We want to find y, the run up here, right? So we want to go rise over run. So 185 over 260. That's what we want to do. 85 over y. That was correct right there. Okay, right, because the unit run that we're trying to find. Alrighty, so cross multiply and divide just like before. 260 multiplied by 85 divided by 185. 119.459. Perfect. 459. Perfect. And we can also call that 120. Okay, 119.459. Okay, perfect. Hope that makes a little bit of sense. Next, the hypotenuse of the plywood. So if you imagine, this is a precursor to finding our stud length here for later. Our 19 mil plywood, if we measure it in the direction that is perpendicular, so straight across, it's 19 mils. But up here, we have to cut it on the angle. So what we're trying to find is if we were to cut this plywood at the correct angle, how long is that cut? That's what we're trying to find. So that little measurement up there. So for that, we draw ourselves yet another triangle. Surprise. We have our unit rise, unit run, and unit of bridge triangle, right? And this is how you see it on the stairs. So just to show how they kind of compare to each other, the 19 mils of the plywood thickness is comparable to the unit run. Do you see that? This is the longer part of the triangle. This is the longer part of the triangle. And what we're trying to find out is the hypotenuse, right? Imagine the hypotenuse going straight up and down. It goes straight up and down here as well. Okay, so let's pop in some numbers. So again, we want to cross multiply and divide. We are using our unit run because that's what we have, and we want to compare it to our hypotenuse. Unit run over hypotenuse. Okay, so 260 over 319.1 equals 19 over A. Again, we pop them into the calculator. 319.1 times 19 divided by 260. 23.3. Awesome. That's it. 319 if you want to be really precise. Okay, great. So that is the hypotenuse length of our plywood once we've cut it at the correct angle. There we go. Boom. Pop these aside. Next, we are looking for the length of plywood from the stair soffit. So what does that mean? Well, let's look. So the stair soffit is what's below here. That's what's called the stair soffit. And we have a piece of plywood here, right? We need something solid across all the joists to keep the concrete in, because when we place the concrete, it's pretty liquidy. If we didn't have plywood, it would just fall through. And we want to find the length that we would need to cut it at. Right? This is all preparing you to be able to actually go ahead and build it. Okay. So again, we're drawing triangles. We have our unit rise, we have a unit run, we have our unit of bridge. Now, what else do we have? We basically are comparing it to a big triangle, right? Small to big. Well, here we have 1565. What the heck? Well, think about it. The total rise is 1665, and that includes the slab thickness, but our plywood goes to underneath the slab. The slab is 100 mils, so we have to take that away from our rise. And that's it. As simple as that. Okay, so what are we comparing? We have a rise, and we're looking for the hypotenuse. So we're going to compare unit rise to the hypotenuse. 185 divided by 319.1 equals to 1565 divided by the hypotenuse, and that is what we're trying to find. Again, cross multiply and divide. 319.1 times 1565 divided by 185. 2699.414. Boom. That is the cut length. Obviously, you have to cut them at an angle, but that is the length. 2699.414. Super duper. Next question. The length of the stair soffit joist. Because the joist runs underneath the plywood, it's not going to be the exact same number. It's going to be close, but not quite. So let's see. We're comparing again, unit rise, unit run, unit of bridge. Same as before, same as all the other ones. Now, what do we have over here? We're still trying to find the hypotenuse, and we have to adjust our rise. Why? Well, the joist runs to underneath the plywood, right? So it's gonna not go up quite as high. So we have our total rise of 1665. We took away the 100, right? The slab thickness for the unit rise, or for the rise for the plywood soffit. But now we also have to take away the 23 mils that is the hypotenuse of the plywood, right? Measured up and down that we had figured out before to get to the underside of the plywood. So it's really just about looking at the plans and taking away the numbers that we need to take away to get to where we want to go. Okie dokie. So what are we trying to compare? We have a rise, and we're trying to find the hypotenuse. So unit rise, hypotenuse. Great. So 185 divided by 319.1, 1542 divided by hypotenuse. That's what we're trying to find out. Again, cross multiply and divide. 319.1 times 1542 divided by 185. 2659.742. Great. Maybe we can call it 2660. Either one. You can see 2699, 2660. It's not that different, just a little bit shorter. Super duper. Okay, next. The length of the reverse stringer. So the stringer that is out of wood that you will be cutting that basically lives above your concrete stairs and gives it the shape, we need to find out how long that is. We find that by taking the number of runs and multiplying that by the unit of bridge. So number of runs, we have 8 times unit of bridge, 319.1. 8 times 319.1. 2552.8. You could also call it 2553. Either one. All great. 2.8. Great. That's that one. Wonderful. Next, we are looking for K, the stair depth. So let's see where that makes sense. We have a couple of triangles. So does this look familiar? We have our regular unit rise and unit run, but when we think about the stair depth, we want to know how, like the measurement from the bottom of the soffit, or like where the concrete starts, to basically the nosing line. That is our K stair depth. So what we're trying to find in this first one is this right here. This is the triangle, right? So this right here, do you see that? So we have a unit rise, unit rise. We have a unit run, but we have to add the nosing. So we have a unit run of 260 plus 30 that gives us 290. So right here. And this little rise here, that's the X that we're looking for, right? We were looking for this measurement, and then later we can add it to the effective depth. And then that gives us our total measurement. So if we're drawing out this little triangle here, we have that we want to compare. We have a regular unit rise, unit run, unit of bridge. And then we have our 290, which is our unit of run plus our nosing. And this is the X that we're trying to find. So I hope by drawing it out like this, you can see the difference that the X isn't the rise, but goes perpendicular right here. So let's see, what can we compare to one another? We have slash are looking for a rise, right? So let's see. We have our 185 over X. And then we have 319 1 over 290. So those are the ones that we can compare here to give us that X. So let's cross multiply and divide. 290 times 185 divided by 319.1 gives us 168.129. Remember, that only gives us X, right? That's only X. So now we need to add our effective depth to give us the whole measurement. Plus 110 gets us 278.129. Awesome. And that's it. 278.129. Awesome. We're getting there. It's fantastic. Okay. So the next one, length of stud A. This is just a practice of looking at the plan, finding the numbers, and seeing where the arrows point to. So the dimension lines telling us where to find what. So let's see. Stud A is this guy. And we have our total rise number that's given to us, right? Which is 1665. Gets us to the top of the slab. So we have to subtract our slab, which is 100. We have to subtract the plywood that's holding in the concrete. We have to subtract the joist. And then we have to subtract the top plate. And then we have to subtract the bottom plate. So let's pop in those numbers. Total rise, 1665, minus the slab of 100, minus the ply of 19, minus the joist of 140, minus the top plate, minus the bottom plate, both at 38. And that's just regular old 2x4, right? The 2 by the 38 is that measurement. And let's pop it into the calculator. 1665 minus 100 minus 19 minus 140 minus 38 minus 38. 1330. That is the length that you get to cut stud A at. Cool. Let's check out the next one. The length of the landing soffit joist. So that's this fella right here. So now we need to calculate in the opposite direction. We just went up and down, and now we're going left to right. So we have our landing length. That is our big measurement. And it goes to the nosing line, and it goes to the inside of the plywood over here. Let's see what it all includes. It includes our nosing. It includes our X number that we found previously. Then we subtract our Y number that we've also found previously, right, to get us to the edge of that joist. That's it for this side. Then we have to look on the other side. We subtract our concrete wall, and we have to subtract that piece of plywood. And that's it. So let's pop in those numbers. So 1800, that's our landing length. Nosing is 30. X numbers from before, we can call it 190. The Y number of before, we can call that 119. Concrete wall, 150, and the ply of 19. Okay, so 1800 minus 30 minus 190 minus 119 minus 150 minus 19. I got a different number earlier. One more time. 1800 minus 30 minus 190 minus 119 minus 150 minus 19. Aha! I obviously missed a number. So 1292. Super duper. Okay. So that is what you would cut that joist at. 1292. 1292. Okay, now we're on to our last question. Hooray! That's awesome. This one's a bit of a biggie. We need to find the volume of our concrete. So we're going to break this up into several steps. First, we're going to find the concrete of our treads. Treads, or the triangles, basically. So what we're going to do is figure out the area of our tread triangle. So basically what we're looking at here. We're going to multiply it by how many of these triangles we have, and then we're going to multiply it by the stair width, right? Length times width times height for volume. This is going to get us length times width, which is the area, times height, technically, so our stair width, and then by the amount that we have. So let's see. Our tread triangle is our unit rise by unit run, right? So 0.29, and now we want to turn everything into meters. So that's our tread unit run plus our nosing times 0.185 divided by 2, right? That's how you find the area of a triangle. Length times width divided by 2 times 9, because we have 9 risers slash triangle steps, times our stair width, which is 900 mils, which is 0.9. Cool, so let's pop that into the calculator. 0.29 times 0.185 divided by 2 times 9 times 0.9. 0.217, and we are into cubic meters, right? Because it's a volume. Next, soffit slab. Soffit slab means the concrete, the slab below all the triangles. So we have our number of risers or steps. We still got 9 times our unit of bridge. That gets us this measurement right here, right? The unit of bridge measurement is that triangle hypotenuse up here, and it is the same on the other side, right? Unit rise, unit run, unit of bridge, times the effective depth, right? How tall is it? Times our stair width. So we get 9 steps. Our unit of bridge, 0.319, times the effective depth, 110, so 0.11, times our stair width of 0.9. Oopsie, sorry. So 9 times 0.319 times 0.11 times 0.9. 0.284 cubic meters. There we go. It's not very much. Next, landing slab. So that's the slab up here. For that one, we need to figure out the length first, because we've already included the triangle and part of the slab over here. So we basically want to take off our nosing and 1 unit run to get us to back here, so we can just calculate the slab. So landing length is 1800 minus our nosing minus our unit run. Go, gets us 1510 or 1.51 meters. And to get the volume, length times width times height. So we have our length that we just figured out, 1.51 meters, times our width is 0.9, times our height is the 100 mils of the thickness, so 0.1. Let's pop that in, 1.51 times 0.9 times 0.1. 0.1359 cubic meters. Okay. Next, we have the wall. So for that, first we have to find the height, because if we did the total height, we'd be buying too much concrete, because the upper portion of the slab is already integrated in the slab volume calculation. So first, to find the height, we have the total rise, 1665, minus the slab thickness. And that gets us the 1.565 meters that we've talked about before. Great. So from here, the volume is always length times width times height. And sometimes if things look funny, they might just have different names. So height of the wall, we can call that length, 565 meters, times the width, right? The width of the wall is the same as the stair width. It's 0.9 meters. And what's usually considered the height is actually the thickness, right? That we haven't taken that into account yet. So 0.15 meters. So 1.565 times 0.9 times 0.15. 0.211 cubic meters. So now that we have our individuals, to find the total, we add them all up. So starting from the top, 217 plus 0.284 plus 0.13, I'll round that 6, plus 0.211. 0.848 cubic meters of concrete for all of it. And that's it. It's a pretty long worksheet, but I hope that that's helpful and that you can take it from here, and you can always message if you have questions and I'll help you out.